Okay, day 4, we're going to talk about three-dimensional composite figures. We've done a little bit on our surface area day, a little bit, I think one example on our volume day. Now we're going to find surface area and volume of 3 more examples. So I'll go ahead and start with surface area. For our surface area, looking at this first composite figure, we have a rectangle and it looks like a triangular prism on the top. Okay, so for surface area, for my rectangle, I've got all of the sides, but I'm noticing the top of this rectangle, I'm not going to be using all of it. I'm only going to be using these 2 portions. So when I find surface area of my sides, it's just base times height. So let's look at this first face. We have this base of 16. Its height here is this 6. So it would be 16 times 6. And also the back side would match it. So I'm going to do times 2. There's 2 of those. Now we have this face. We have 4 by 6. So 4 times 6. And there's 2 of those because the other one's matching over there. So times 2. Then we have the bottom of our rectangle. That's 16 by 4. And there's not 2 of those because the top of it, we're not using the whole piece. So we need to only figure out this part. So if from this base of the triangle from here to here is 12 and the entire thing is 16, then I have 4 left over. I split that in 2 chunks. This is 2 and this is 2 then. So this rectangle is a 2 by 4 rectangle. And there are 2 of those. So 2 times 4 times 2. Right? Then we need to find our surface area for this triangle up here. This triangular prism. So if the height of my triangle is 9, part of the base here, or the whole base is 12. I can find both of these triangles because it's 1/2 times base times height, so it's 1/2 times the base, which is 12, times the height, which is 9, and there are 2 of those triangles, so times 2. Now I need to figure out this rectangular part of my triangular prism. So that's again base times height, so this is going to be 4. Now I'm not sure what this is here. I can figure that out by using one of these triangles. So I'll kind of pull it out. The height is 9. If I'm using half of the base, so the base would be 6, now I can use Pythagorean theorem to find this missing side. So that's 6 squared plus 9 squared equals x squared. You could use any variable. If you like c, because it is the hypotenuse, you could use c squared. So 6 squared plus 9 squared and we need to square root 117. So x squared equals 117. Square rooting that, we get 10.8. I'll just round to the nearest 10th. So x equals 10.8. That is the height there. And I have 2 of those rectangles, 1 on each side of my triangular prism. I don't use the 3rd one because that is not on the surface. It's kind of sandwiched between the composite figure. So I'll do again 4 times 10.8, and there are 2 of those, so times 2. Take a second and calculate all of these in your calculator or in your head. Okay, double check your measurements with me. I have 192, 48, 64, 16, 108, 86.4. So that's the surface area combined. Now I need to add that all up. So my surface area, adding each of these up, I have 514.4, we're talking inches, and then because it's surface area, inches squared. Now volume. So volume over here, I'll break this up into chunks. I have the volume of my rectangle, and then I need to add the volume of my triangular prism. So first, I'll just label that I'm working with my rectangle first. So the volume of a rectangle is base times width times height. So I have 16 times 4 times 6. 16 times 4 times 6 gives me 384. Now working with my triangular prism. Okay, so for our triangular prism, our volume equals the base area times the height. So the base area, base of our triangle, so that's 1/2 times base, 12, times height, which is 9, times the height of our triangular prism. Remember, this is the distance between the two bases, so this is where the 4 comes into play. So times 4. Do that in your head or plug it all in. So 0.5 times 12 times 9 times 4. I got volume is 216. To find the volume of the entire composite figure, we would just add these two together. So 216 plus 384 gives you 600. Still talking about inches because it's volume, it's now cubed. Part B. So when I analyze part B, it looks like I have a cylinder and then 2 spheres on each side. It kind of looks like a capsule. These 2 spheres are hemispheres, but if I combine them together, they do make an entire sphere up. Okay, I'm noting I'm given the height of my cylinder, and I'm also being given a radius. Okay, if this is my radius from my sphere from the center to the outside of my cylinder, the radius would be the same here. All right. So first, let's start off with surface area. You may, if you want to organize your work, you can divide it up. So surface area first, and I'm going to work on my sphere. So for my surface area for my sphere, it's 4 pi r squared. So I have 4 times pi times r squared, so 6 squared. And I want you to note for these composite figures, I do not expect you to keep it in terms of pi, so we will go ahead and round to our nearest tenth. So I got 452.4. 452.4. All right. Then finding the surface area for our cylinder. Our cylinder, the surface area. Notice that for our, if it was just a cylinder, I would have to use the circle on the top and the bottom. But because this cylinder is being enclosed by 2 hemispheres, the surface area for my cylinder that's showing is only the rectangle all the way around. Okay, and remember we calculate that by 2 pi r because it's kind of circumference, and then the height we call L or H, 2 pi r H, height. Plugging in what we know, we have 2 pi, r is 6, H, height of the cylinder, is 11. Plug that all into your calculator, again, round to the nearest tenth. I got 414.7. 444.7. Okay. Surface area entire figure. I'll just take these two and add them together. So 452.4 plus 414.7 867.1. We're talking about feet here, and it should be feet squared. Finding the volume of this figure. First, I'll go ahead and work with my sphere. Okay, I have two hemispheres together, they make a sphere. So our volume for a sphere is 4/3 pi r cubed. Plugging in what we know, we have 4/3 pi, r is 6 cubed. Again, round to the nearest tenth, please. Recall, in order to put 4/3 in your calculator, you press alpha, y equals enter. 4/3, arrow to the right, pi, and then 6 to the power of 3. 904.8. Take the 7 behind it, tells it go up. 904.8. Now working with my cylinder. The volume of my cylinder is pi r squared times the height. I got that because our base area is the base of this circle down here, and then I'm timesing that by height. Plugging in, we have pi r is 6 squared times our height, which is 11. So pi 6 squared times 11. That number, rounding to the nearest tenth, 1,244.1. Our volume is adding up both of these pieces. So take a second and add those in your calculator. 1,244.1 plus 904.8. So our volume should be 2,148.9. Still talking about feet because it's volume, feet cubed. Example 3. So looking at this, it kind of just looks like a snow cone. So we have a cone, and then we have a sphere on the top, but the sphere has been halved. So the vocabulary term for that is hemisphere. First, finding the volume, I'll go ahead and start with our cone. So I'm going to work bottom up this time. So our cone equation is pi r L. So it's kind of half the circumference, and then our L is that funky height. It's like the slant length. So if I look at this triangle here, I know that this is going to be 15. I have my radius is 10. I'm thinking eventually I'm going to have to find this L. Okay, and in order to go ahead and plug it in to this equation, I need to stop for a second and use Pythagorean theorem to find L. So our L is our hypotenuse, so 10 squared plus 15 squared equals L squared. 10 squared plus 15 squared, oops, is 325 equals L squared. Square root both sides in order to find L. And let's go ahead and round to the nearest tenth. So L would be 18. 18.0. We'll just stick with 18. I'll label that on my picture. Now working with my cone, pi, stays pi. R, my radius is 10. My L, slant length, is 18. Plugging that into my calculator. I labeled this volume, but this is surface area. Please correct that if you wrote down. So we have pi times 10 times 18. 565.5. 565.5. Okay, then we would need to go ahead and find our surface area of our sphere. And it's a half of a sphere, so let's go ahead and write hemisphere. Our our hemisphere, if we're finding the whole sphere, it's 4 pi r squared. Because we're finding half of it, you can throw a half out in front. If you just put a 2, that'd be fine. But I would start out with half. Then we go ahead and plug in for r. So 1/2 times 4 pi r squared, so 10 squared. Plugging that all into your calculator. $628.3. Our entire surface area is adding these two pieces together. So 628.3 plus 565.5 should get 1,193.8. And it is yards squared. Last chunk is volume. So if I was to fill this entire figure up, how much room do I have? Volume. Let's go ahead and start with our cone first. So our cone has a special formula. It's 1/3 times the base area times the height. So volume is 1/3. The base area, our base of our triangle, or sorry, of our cone is a circle. So area of a circle is pi r squared. So times pi times r, which is 10, squaring that, times the height. So this is the entire height here, and we'll go ahead and use 15. It's not L or slant height and height. Plugging that all in. Do not use 0.3. You must use 1/3. Plugging that into your calculator. If you use 0.3, it is rounded and it will not give you the exact answer. 1,570.8. Okay, lastly, we need to find our volume of half of the sphere, so our hemisphere again. Okay, so we're going to half the sphere volume formula. So the sphere volume formula is 4/3 times pi r cubed, and you will be given this formula. You just have to be able to identify that this is the one to use. Plugging in for r, so I have 1/3 times 1/2 times 4/3 times pi times your radius, which is 10, cubed. Take a second, plug all that into your calculator. I'll show you me plugging it into mine. Alpha y equals enter, 1/2, and let's times by 4/3, then times pi, then times 10 to the power of 3. 2,094.4. Okay, our entire volume of this whole snow cone looking composite figure is adding these two pieces together. So 2,094.4 plus 1,570.8. Our entire volume is 3,665.2. We're using yards, and it should be cubed since it is volume.